Okay, so we have covered describing motion for the last couple of weeks. Okay, so in general, what is motion? Yeah, just a movement, right? Okay, so motion is just like a movement, and that can be measured if we want to describe how fast that object is moving. We would find how fast the distance or the displacement is changing with respect to time, right? So that's velocity or speed is equal to displacement or distance over time. Good. Great. So, who can remind me of a scalar quantity, and who can remind me of a vector quantity? Maria, can you help me out? What is a scalar quantity?
Scalar quantity that has speed only in one direction.
Perfect. So just like a magnitude only?
Yeah.
Yeah. So magnitude only, no direction. Okay, that's very important. And then one example of a scalar quantity would be speed. What's another one?
Distance.
Distance, yep. Time, mass, to name a few. Good. And that brings us to vector quantities. So Kyle, if a scalar quantity has only a magnitude, what does a vector quantity have?
We have both a magnitude and a direction.
Perfect. Has a magnitude and direction. Okay, so some examples of that would be velocity, displacement, acceleration, to name a few. Okay? So scalar and vector quantities. Good. So scalars are simple, essentially, right? They only have a magnitude, and vectors are a little bit more complex. They have magnitudes and directions. Remember, vectors will have like their little vector hats as well, if you're trying to distinguish between the two. All right. So distance versus displacement. Which is a scalar quantity?
Distance.
Distances. And displacement is going to be a vector. Okay. What is distance? What is distance?
The length between 2 points.
The length between 2 points, yeah. Okay, so length. Or also the total distance traveled, right? Total distance traveled. Okay, so for example, right now, the distance that I've traveled is like 100 kilometers from my house, right, to get here. It's 100 kilometers. Once I return home, my displacement will be 0, right, assuming that my home is the origin, right? So I kind of just hinted to it, but what is displacement?
How far away you are from the origin.
Perfect. Perfect. How far we are from the origin. Good. What are like the symbols for distance and displacement? If you're looking at your formula sheet, what would distance look like? Delta D, yeah. And will it have a vector cap? No, because it's scalar, right? Good. And what does displacement look like?
Delta D with the cap on.
Yeah, delta D with the cap on. Good. Good. Okay, good. So speed versus velocity. So Tanner, is speed a scalar or a vector quantity? Scalar, good. S speed, S scalar. Which must mean that velocity is my vector. Okay, velocity, vector, V and V, right? Good, easy to remember that. Okay, so how do I measure speed? If it is a scalar quantity. Am I going to use displacement for speed? No. Distance, yeah, good. And how do I find my speed? Do I just measure a distance?
Distance over time.
Distance over time, good. Okay, so you might see this on a formula sheet looking like this. V is equal to D over T. And again, we don't have any vector caps on V or D, so we will assume this is scalar. So this is going to be our speed formula. Okay, so what is velocity then? I'm going to use distance here for velocity. Displacement, right? Yeah, velocity is a vector. So velocity is displacement over time. And if you look at it on the formula sheet, you might see V with the vector hat over delta D over delta T. Okay, and this one we might see T as well. And what does that little triangle tell me?
Change.
It's a change in something. Good. So anytime that you're doing a change in something, it'll be D2 or 2 minus 1, final minus initial, right? So D2 minus D1 over T2 minus T1. Typically you're going to be using this used in graphing. And we'll talk about that in a second here. So just kind of extending what we did on the speed side, we might see velocity is equal to the second displacement minus the first displacement over T2 minus T1. Okay, so speed and velocity similar, but not the same, right? Same, but different. All right. So here is what we just talked about. Average velocity is displacement over time, and speed is distance over time. All right. So we've talked about displacement, we've talked about distance, we've talked about speed and velocity. Now, what is acceleration?
The rate at which the object speeds up.
Yeah, perfect. So the rate of change, or like how the velocity changes with respect to time, right? Yeah, beautiful. So acceleration vector is equal to the change in velocity over the change in time, which can be expanded to V2 minus V1 over T2 minus T1. Good. So acceleration is a change in velocity over a given time period. Yes. Okay. And okay, good. So this brings us, here's our graphing part. So I just kind of gave away the answer. But how do we communicate the motion of objects? Through graphing, yeah. Graphing is how we do this. Okay, and graphing is pretty helpful for us because one, it helps us communicate like what the motion looks like, right? Like for example, when we collected our data in our lab last week, you would never present that data to somebody and be like, look, this is what it looks like when somebody's walking, right? You would produce a graph and you'd give that to them. You'd be like, hey, this is what it looks like when somebody's graphing, right? You wouldn't just give them raw data, right? You would put it into the form of a graph to allow the reader or whoever's looking at the graph to easily observe it better, right? Then they don't have to interpret our data. Good. Okay, so we had two types of graphs that we looked at and two types of graphs that you guys made on that assignment. What were they? What was one of them?
Displacement time graph.
Perfect, so one of them was a displacement time graph. So I'm just going to say d-t, displacement time graph. And what was the other one? Velocity time graph, v-t, good. Okay, so displacement time graphs. What goes on the x-axis? Time. And what will go on the y-axis then? Displacement. Okay, so when you guys make your graph in today's quiz, make sure you have a title and you label your axes, okay? So this is going to be displacement. This will be time. If somebody started at an origin, like we did in our lab, and we just kept walking in one direction, it would look something like that. Okay. What will, so if I find, okay, what does the slope tell us on a displacement time graph? It tells us the velocity, right? Good. And if in general, I wanted to find the slope of a line, how would I do that?
Rise over run.
Rise over run. Good. Okay, on a displacement time graph, the rise is our displacement. So it's going to be delta D on the rise, and my run is going to be change in time. Okay, because we are graphing, okay, to find the change in distance or the change in time, it will be the second time minus the first time divided by, the second displacement minus the first displacement divided by the second time minus the first time. So just like Abe had said, slope on a displacement time graph tells us the average velocity. Okay, and our units can help us with that. What is distance or displacement typically measured in? Meters. And what is time measured in? Seconds, right? So if we divide the change in rise over the change in run, we will get meters per second as our units, which are the units for velocity, right? Okay. So, moving to a velocity time graph, and hint, this is what you guys are going to be creating today. Okay, so make sure we're paying attention here. What is going to go on my x-axis? Time. Good. Time usually always goes on the x-axis. And then what does that leave for my y-axis? Velocity. Good. And as we just said, what are the typical units for velocity? Meters per second. And if this is seconds, typically. Let's say car is started or car is stopped at a red light, right? Just trying to get to school, red light's in the way. Light turns green, we increase our speed to, I don't know, 20 meters per second in 5 seconds. Now we have a point, 5 and 20. I would really encourage you guys to write your ordered pairs down when you are creating your graph. It's just going to help you organize the information that's given. Okay? Yeah, so it's driving at 20 meters per second. It cruises at this for, say, 10 seconds. So we have 15 in total. 15 is our x. Our velocity is still 20. And then it comes to a rest in 15 seconds from there. Okay, so my last point is going to be 30 and 0. Okay, so I'm stopped at a light. I accelerate. I reach my cruising velocity of 20 meters per second until I see another light in which I slow down. Okay? What if I found the slope for this region right here? And that's the straight line right there. Okay, if I found the slope on a velocity time graph, what will that tell me?
Acceleration.
It will tell me the acceleration, right? Because on the rise, I have my change in velocity. On my run, I have change in time. So same thing, it'll be V2 minus V1 over T2 minus T1. Units for velocity, meters per second, divided by second. Slope equals meters per second squared, which are our units for acceleration, right? Okay, good. How would I find the total displacement on a velocity time graph? Find the area underneath. Okay, that is really important. You need to know that for today. Okay, so put a note, put a star somewhere. To find displacement on a velocity time graph, find the total area under the curve. Okay, you need to know how to do that. So write that down, burn it in your brain. Okay, so in this example here, if I wanted to find the total displacement, I would break this up into 3 shapes. 1, 2, 3. Okay. Area of triangle is equal to length times height divided by 2. And area of a rectangle is equal to length times height. Okay? So my length here is 5 seconds. My height is 20. So 5 times 20 is 100. Divided by 2 would be 50 right here. Plus this area, plus that area. Okay? This will be, what will my units on displacement be? Meters. Good. And a direction. Yeah, you bet. Okay. So, if I asked you to calculate the acceleration, so we already talked about that, you would find the slope of those lines, right? So V2 minus V1, V2 minus V1, and T2 minus T1. Okay, so you will be asked to find the acceleration of one portion, and you are also going to be asked to find the acceleration of another portion. Okay? What acceleration, either the red or the blue, would we expect to be negative? The red, yeah, for sure, right? It's a negative slope. It's going down as it progresses, okay? So if you get a negative acceleration for one of the regions on your quiz, okay, do not worry. Okay, that's should be expected, right? If you're going this way, that is negative acceleration. Good. Speeding up, speeding down. Positive acceleration and negative acceleration. Okay? Any questions so far? No? Okay, I feel like a lot of this we talked about. So we talked about slope already. We talked about positive and negative acceleration. So remember, this is a velocity time graph. Which one has positive acceleration? The one on the left. Good. And that must mean the one on the right has negative acceleration. All right. So that's it for our review.